Hello everyone, good to see you. Today we're going to talk about flatness with modifier. Let's see this example. The height of this component is going to change between 29 and 31. It is 30 plus minus 1. And we have the value of flatness for mid-plane, it is 0.1. First, we are going to calculate the virtual condition. For this component, MMC is important. We are going to calculate the maximum distance between two horizontal planes. It can be 31.1. No matter what is the thickness of this component, for all thickness, the tolerance zone has a constant value 0.1. Let's add modifier here. What is going on here? We are going to have the same value for virtual condition. But for different value of the thickness of the component, we are going to have different value of tolerance zone for mid-plane. If the thickness is 29, we are going to have 2.1 as a tolerance zone for mid-plane. If the thickness is 30, we are going to have another value for tolerance zone. And finally, for let's say MMC, when the thickness is 31, we are going to have the lowest tolerance zone, it is 0.1. They are listed in last column in this table. Let's see this example. The distance between these two planes is 25 plus minus 1. This gap can be 24, 25, 26. And we have the flatness of the midplane 0.1. In this situation, the LMC is important. We are going to calculate what can be the virtual condition. It can be this value, 23.9. No matter what is the value of the gap, we are going to have the constant tolerance zone for the midplane. It is 0.1. If we are going to add modifier here, as we can see in this figure, based on the value of the gap, we are going to have different value for tolerance zone for midplane. We are going to have a dynamic tolerance based on the gap. Now we have another example here. The tolerance zone for midplane is 0.3, and the thickness of this component is going to change in this interval as they are listed in the first column here, as we can see. Again, we are going to calculate the virtual condition. For this component, MMC is important. We are going to calculate what can be the distance between these two horizontal planes. We are going to have this value 20.5. If the component is going to sit on measuring tool, and whenever we are going to have this box, for example here, it can be 20.5. And based on the height of the component, we are going to have different tolerance zone for the midplane. We have several standards. Here I am listed JIS and ISO 2768 based on the dimension of the component and let's say tolerance class or degree, we are going to have different values for flatness. Based on application, we are going to use the class of that surface. If, for example, two phalanges see each other based on the cargo in that, let's say, pipe, we are going to use different gasket, and for sure we need to use this flatness symbol. Thank you for today. I would like to close this session regarding to flatness. In coming session, I'm going to talk about the straightness. I hope you enjoyed. See you next time.